What are we reading here? 9:14 a.m. Not bad. 9:14 a.m. Pacific time here on the west coast of Canada. Casually hanging out in the cold weather. Here in a beautiful December. Certainly not the dark night that it must be in Denmark. Probably rolling in at 5:14 p.m. here in Central European time. Welcome to another edition of BUILDNESDAY. BUILDNESDAY is where we build software. It's where I work on projects that I want to do because this stream is about me. And maybe that's kind of unfortunate. I should rethink that strategy overall if I want this to be engaging. But that's not going to happen because today I'm building software that I want to build. And actually, I've been building that software all week long, ever since I got the Pro subscription for GitHub Copilot. Girl, it's the robot that writes the code. Girl. And I'm just prompting. I'm just like, hey, what do you think I'm missing here? What's missing in the specification? What are you misunderstanding? And it's like working with a friend who's an expert, but doesn't know where I'm at and doesn't understand what I'm saying because I'm not an expert myself. So the pleasure is imminent, I would say. Let's just see what documentation I've got here, where I left off. And let's funnel audio here. Nice. Audio check. Let's take a look, dive right in here. Looks like we're dealing with some, let's make sure this is up to date. Let's make sure this is up to date. I think it absolutely is. 2 days ago. Fixed element model. And there's no changes right now to commit. Did I ever make this commitment? Feature, UI, streamline admin dashboard layout. I don't think I ever committed that directly. Let's just take a look for features here in the git commit train. Can we search this? No. No. Oh, we certainly did. Look at that. We committed this ages ago. Great job, everybody. Great. We can close that chat. Wow, we committed. We haven't developed on this computer since last week is the truth. Oh my gosh, yeah. 4 days ago with 356 insertions and 170 deletions. Great job. Yeah, which also means that if I go into our source control and I just fetch from all the remotes, it's not going to change anything. It doesn't. Boy, developing in VS Code across multiple machines, very slick when you have that VS Code server running. Just connect to that one instance. I never have to update my Git repositories. Fetching is done automatically. My AI needs to be logged into each time I want to use it on a separate machine. I don't know why that is. I have to do local authentication to use the AI through the VS Code remote UI. But I'm just using Remote Code Explorer. There's nothing fancy going on here. Just Remote Explorer with my machine. This machine is actually the dev machine itself, so we're working locally. We're doing it live. Absolutely good morning, everybody. Kind of a hazy day today here. But it puts me in a good mood for coding. This is the time for us to code together. I love that sound effect so much. It's time to code together. So I was thinking, let me bring you on page here. Let's do a little drawing. I was thinking the following. So we've got this idea of, oh, you know what? Don't we have an existing diagram of the whole stream thing? Yeah, discard the changes here. Open up me existing diagrams, if you will. Here we go, the overlay concept. I'm actually just going to make a copy of overlay concept here, and I'm going to call it overlay concept version 2. And this is more of a, let's see, December. Ooh, we've been working on this for a month, honeys. A month. Oops, that didn't rename quite right. Oh, and even when I zoom, you guys can't see bigger text. Windows is so cringe, I see. Well, it is what it is. Here we go. I keep the editor text nice and big for stream so you guys can read that. So let me know if there's anything else I could bump up. Yeah, we'll just call this overlay concept version 2, but I want to propose a user structure where we start to database all of the user interactions we have for our little game. And I want to implement a Family Feud game so that we can play Family Feud on stream together. And maybe it's just me playing Family Feud alone. That's fine too. Show me lonely. Ding. Yeah, I do this for fun. Don't worry about me. Don't worry about me. Maybe someone will use this software one day to play. I'm calling it Friendly Feud, by the way. We don't want to get sued on this stream. I'm just going to start calling it Friendly Feud right away. It is in no way inspired or a derivative work of Family Feud. It doesn't have any of the core elements or scoring components. It's just a fun little game you do that makes dinging sounds and reveals answers that you guess at, which could be like a lot of games. Nice. Okay, let's crack this open. And the modification I'm proposing here, like this was the original draft, right? We were talking about building a Python program, which we've built, which creates an overlay, a web overlay, which it does, that OBS uses to view interesting things that we put on that website, which it could. We haven't tried that out, but obviously it works. It's just a website hosted locally. Using Tailscale, I connect all these computers together too, so it doesn't even really matter which computer it's running on. With Tailscale on it creates a VPN effectively where all of these devices can just meshnet without interrupting their existing network services. They just can access these additional components. So we've got this huge pipeline. We've got this thing happening, and we do use some animations. We're not really using GSAP or Anima at the moment, but we will in a second. We're going to use it as a flip animation for this Friendly Feud implementation. And so it plays sounds, it shows images, it has a management endpoint where I can trigger the interactions and I can trigger actions to animate and make fun things happen. We've got it all set up. There's a whole framework. And all that needs to happen, maybe I should add that here. All that needs to happen is that you build widgets in this software system. Is widget a shape I can search? No result for widget. Widgets. Let me just think. It's like a package. Oops. Yeah, widgets are like the packages that do the thing. So this Friendly Feud component, it's actually going to be a Friendly Feud widget. For example, Friendly Feud, or I have an alert widget that I've built as a prototype for widgets. And that just exists completely within this Python program here. Let me just create a little bit of space. Streaming computer does not really matter here, honestly, but you do need data to come from streaming computer, I guess. That was the point. Yeah, let's just leave that linked. Good. So these widgets, they're really the whole component internal, and so you can develop as many as you want. That's the key feature here. Here's the code, yeah. I want widgets to be part of like an asset of the program. Yeah, like this, exactly. And let's just send this to the front. To the front, thank you. And we'll move these other little components over. Here we go. Nice. A lot of things are working here right now. So widgets now with our Friendly Feud widget in play, we just need to connect the widget to the chat. And that's where this last goal comes in. This is the last thing. We haven't implemented this at all. Well, I guess we haven't implemented detecting fun things on the microphone either. And that's kind of, yeah, that's probably going to be really easy. Honestly, knowing the interfaces we've got, Python makes it so easy to acquire microphone input, so don't even worry about that. The Twitch API, that's what I was thinking we develop. And like insofar as we develop a Twitch API, we want to make sure we have like a broader perspective on the long-term development, which means not just Twitch, it means YouTube. It means a whole communication interface, you know, a whole communication management system or portal or provider or however you want to call this. I think more appropriately, it's like, it's a whole server, you know, and it hosts whole chat types. It's Twitch, it's YouTube, it's TikTok, it's Discord, it's everything, right? Yeah, let's just tuck these, format these left. I think we know what we're up to here. So it's kind of a bigger idea. It's the bigger piece here is managing communications from many sources and making them uniform enough to interact with our program so that this Twitch API actually becomes a secondary interface where the communication server that we build out here, it's gonna replace or fully interface with Twitch, where before we had direct communication in our program. I don't think we want to build this overlay program to be a Twitch specialist. That's the truth. Now, I know there's some implications here. It's not going to work out of the box for people who want to just plug in their Twitch credentials and start running it. Well, not necessarily. If we build the communication server as its own Docker module here, then we could promise that. We could build a stack, a Docker stack, where the communication server is one part, and where our Python program fits into the other half. We should group some of this up. I'm going to group some of these up. We'll just group those up. We'll group widgets and this thing up. Yeah, hopefully that makes sense. Group. Nice. And let's just say that, yeah, this streaming computer, that's where good things can happen. Oops. We'll group these three up. There we go. Nice. It's nice to build a nice diagram, you know? It feels good to have something productive and clear. It's quite attractive, actually. It's one of the nicer diagrams we've done on the stream, to be frank. I mean, if we printed this onto some nice paper, this would be a nice product. You know? It looks official even. Okay, someone technical would tear this to pieces. Let's not get too full of ourselves. It's just a fun diagram for us to plan. And it gives us the space to add, let's see, the YouTube logo here. Let's just grab some little assets. Oh boy, needlessly large. Needlessly large. Is there a smaller one? Let's take a look at all the sizes. Yeah, let's get a little one. 128 pixels, please. Yeah, open that up. Can I copy that? That's great. Does this work? Wow, I can just copy. Fantastic. Beautiful. Right, so it's Twitch API, it's the YouTube API. These are going to be the main communication interfaces for us. And let's go all the way. Yeah, Discord. I think Discord's going to be pretty easy to interface with, right? Let's just check ChatGPT. Does Discord have an easy to use API for programmers in Python? Well, what happened at the start of that data collection there? The microphone went wild. Discord, it nailed it though. Yeah, we're just using some weird webcam as a microphone. Yes, programmers of Python can conveniently use Discord's API. Discord.py. Love it. Few caveats. They're not official. You need a reasonably update version of Python. Okay. Short, yes. Yeah, cool. That's all I need to hear. This logo's huge. That's fine. I can't seem to copy from there. Let's try. Oh, this one's kind of fun with the weird circle. Let's take a look at that. Copy image. Is it not an image? It's embedded, but you can't download. Yeah, I can. Save as. Oh, it's a whole complete web page. I see. Interesting. Okay, they've somehow protected this. Can I download from here? Copy image. Does this work? Oh, straight up. Honey, straight up. Can we just change the size, please? Arrange, style. Edit link. No link. There we go. Okay, it doesn't scale for some reason. That's interesting. Discord Overwatch icons. What? That's so specific. What about this one? No, it also has that weird web wrapper. I guess that's just part of Google's interface. We'll take anything, though, at this point. Like, can we download? Wow, it's hard to download images now, eh? What happened? And then I can copy from Windows. Interesting. Yeah. Sad. It's a sad world, right? 2025. Let's go. All right, beautiful. That kind of completes the picture I wanted to draw, though. I just wanted to say multiple services are feeding into one communication server. So today we could be developing that communication server that feeds into our bigger software. Yeah, it's kind of like, it means a new project, effectively. But it's part of the same project. We need this thing to be chat interactive. And the overlay is working. The overlay has its rudimentary beginnings now. It plays sounds. It makes images. We could be using it right now even to do fun little things. But let's have a big reveal with all the pieces combined, I think. It was part of the original specification. It's not meant to be bonus features. The idea of a stream companion that doesn't have chat interaction is kind of like unhinged, I think. A little disconnected. Nice. Right, I have streaming computer here, but isn't that where OBS is running? Probably. Yeah, let's just update this image a little bit. Let's put these assets. Sound and video. That didn't render nice. Oh, I'm loving this diagram. We could first draft out some specifications for the communication server, and I've got a little bit of, I've got some models ready for our chat interaction that I already drafted. Let's take a look at where I left off. This is just basic stuff. Like, we're just trying to communicate to the AI exactly what we need in a user system, so that we do need these 3 particular endpoints at least. let's see here, dev chats, play repository. Here we go. Yeah, where did we leave off here? I was saying, let's continue to develop minimum features in the README. This time, a platform account, platform person model. It may seem complex. It captures the idea of receiving messages from third-party chat APIs like YouTube and Twitch and mapping those messages to a person internal to our system. Yeah, we should take this description and just move it into a new project and get started on a fresh project. How is our chat allocation? Okay, we've used 81.3% of our premium requests. And our allowance isn't going to reset until December 31st at 4 p.m., I'm told. Shucks. Which means that we're going to end up paying more. We're going to be paying more. I'm definitely not slowing down on my premium requests. I've used a ton. I'm going to keep using a ton. I'll try to use chat when I can, free chat, because now I recognize the value of these premium requests. I don't want to be casual. I don't want to accidentally ask the computers to do things I don't need done with my code. I want everything I do to be strongly intentioned and high value for the outcome. So what did we describe up to this point? Well, I described, we should draw a little picture here too. So let's just get one. The database model is that there are platforms. Yeah. Here, I'm going to save this and let's start a new diagram here. Stream companion. Here we go. Dev diagrams. Here we go. Now it's going to have a user system. Well, I guess we were calling it the communication server. A little generic, I admit, but we'll make the name configurable. I just want to make sure it's separate from the rest of our program so that I can manage all these identities across multiple pieces of software. Like, we're developing this one overlay system. The overlay system shouldn't be the main chat interactor with my stream, right? They should be separate components in one stream package, is my opinion. So maybe I ensconce that here in the bigger picture. There's two components. Half of it is the streaming companion, and the other half is a communication server. Communication between the two exists. In fact, the stream companion relies upon the communication server. That's the biggest picture. So just to clarify where we're at in our development. And right now I want to work on the communication server part. So let's just take this and expand upon it. And by defining the roles in the database, first I'll just say that there is a database. Oops. Let's get a little database. I guess just cylinders are fine. Platforms, that is the platforms that we're communicating from. Platform accounts. These are the different accounts that show up that communicate on those platforms. Why? I don't know why the text here is bold exactly. Was it always that way? Platform accounts. Oop. Redo. Okay, nice. No, it was weirdly added as an editing. Okay. Platforms, and we'll style left here. Platform accounts. let's see, we've got person roles. Those are the roles that people in the system have, and persons, of course. So we're going to need to have persons. Persons. Person roles. Maybe we should add roles as well to the database, just to be really formal about it. Roles. Linked platform account. Oops. And this linked platform account is a registry. Is this not taking whole control? There we go. And linked platform accounts is a table that helps us to link together accounts in case we need to elevate the privileges of multiple people. Like, for example, if I've got a mod who has a YouTube account and a Twitch account, I want to give them the power to moderate across all the platforms at once using my interface. So let's give them... let's link their accounts so that they're all moderators, so that every account gets to be a moderator. And when I add those privileges or other roles, all those roles would automatically be inherited for a person. A person would still basically look like a Twitch handle, but it could also be like a Twitch handle plus a YouTube handle. Nice. Oh, I love that. Yeah. Whoa, okay. They've blocked a lot of ads for me. Thank you. I guess there were some ads coming up there. Thank you. Okay. Close. This computer will be wiped, I'm sure, eventually. Just can't trust Windows these days. I feel like you gotta absolutely format that hard drive every year. Hot takes here. Cool. So that's kind of that's the bigger piece that we designed for roles and persons and management. And as soon as I finished this description, I knew it was too much to implement in just the Stream Companion. Stream Companion already has so much going on, right? Stream Companion already has all of the overlaying nonsense. It has all of the overlays and all of the the widgets. It has a full database of all this stuff that it maintains. Yeah, here, get the database out. It's complicated. Yeah, it's got a database of elements, widgets. Well, the widgets are kind of in code, to be honest. But the widgets have the elements, and those elements are inside the database. All of the control panels are here. Yeah, which we're calling dashboards. It's everything that needs to be manifest. It's everything you need to load. And widgets are one of those things. Yeah, I should say so. Nice. Nice. Okay, perfect. Yeah, there's already so much going on, I think, with the streaming tool that I didn't want to complexify it any further. This is honestly absolutely enough to chew on. This has such an unfortunate routing. Okay, that's fine though. Communication server, check. And by leaving this server independent, we're also able to run it 24/7. So if we have chats or communications that come in while I'm not here or off hours, they can still be monitored and honored in whatever form they're meant to be. Like if commands are being issued and people have the role and the authority to run those commands, we should let people run those commands. Just because I'm not here doesn't mean chat shouldn't work. Okay, and then I started to work on the domain entities. These are the actual manifest objects inside of the Python program. So the kinds of things that are passed around. And a person made sense. That's going to be part of the API, I think. persons will be the ones who communicate, and persons have person accounts. So think about that. It's like there's a person or a user, I guess. And they have multiple accounts. What are these crazy images for account? Agent, organization management account, AWS account. Yeah, well, they look like the kinds of accounts from that previous diagram is the truth. They look like... Oh, I can't have two of these open at the same time. That's really too bad. Yeah, it's Twitch and YouTube and stuff and Discord. So we'll just call them organizations. Sure. Do any of these look like... Sure. And I'll just be like, it's YouTube. Person accounts. Like, it could be a wallet or something, right? Here we go. Yeah, it's just like a weird little wallet. And then maybe you've got like a few person accounts, right? Nice. So we've got persons, we got person account. Oof, the text here is so non-uniform. Can I just add my own text? That's so unfortunate. Let's see here. Text. Bottom. Nice. Okay, that's perfect. Person account. And we'll make the background color. Nope. Perfect. Might have multiple person accounts as well. And let's see here. Person accounts have a platform. How do you say platform? Yeah, here we go. It's another whole system. Platform. Yeah, we'll just use this little web icon. We'll just say these. These are platforms. And of which, oh, sorry, not person accounts, platform accounts. Excuse me. And platform accounts each have a platform and the necessary pieces there, like a username, whatever else identifies the account. And then the person roles, that's kind of a separate system. Is there a role icon here? Yeah, we'll use this as a role. Can I get another role? Little hat, little different role here. Oh, I like these little role hats. Yeah, they're wearing different little hats. Let's take a couple of those. Shadow, formatted text. Can't really change the color of this overall. That's fine. And we'll just say these are roles that users can have. Oh, that a person can have, excuse me. And font color. There we go. Person can have roles. And the roles can be used in the logic. They can be governed through the API endpoint. Like a moderator, for example, so that we can set moderation standards. And we can let users interact in different capacities if we like. Great, so that's 4 of the entities here. Now, person roles. Does person not own their own roles? Platform accounts, person roles. This isn't quite fleshed out, is it? Let's take a look at the documentation here. Person roles. Oh yeah, person role just groups person to role to formalize the relationship. Because it's hard to query the database if we don't separate the roles and the role relationships. And I need to be able to select all of the people who have specific roles. That's the truth. And right away, once you have those people, I need to be able to select all of the accounts from those people, which is easy once you have the people because all of their accounts are listed inside of their persons, right? Let's see here. Platform accounts, persons. And I was going to use linked platform account to connect persons to their accounts. See, that may not be necessary. Although it's nice to have that as an individual entity, because then you can write a note that describes the context of that linking. I got to think about that for a second. That seems awfully good, actually. Yeah. Yeah, am I keeping the database too simple? I don't think so. I think this scheme is correct, and the linking is nice. Maybe my models will be different inside of my system, but the database should be solid this way. The scheme should be solid. Let's see here. Database model. Yeah, it is supposed to be a database model. Okay, I'm fine with this then. It's very highly flexible. The ownership by list of persons is clear by this diagram anyway. How it manifests in the domain entities, that's up to us on the fly. But yeah, a person can have multiple roles. These are related by tables like linked platform accounts. We'll just group these together. And roles are grouped together by, to the person, excuse me. They're assigned to the person via the person roles table. So person has platform accounts, person has roles, and the linking in the database is just done by these relational tables. That's all. And that's for the purpose of fast querying. The user service could get really big, you know? The user service could be really, yeah, it needs to be performant. Let's take a look at those extra key points here. Key ideas. Performance of the, I don't want to call it the person service, but it's like communication server. Is intended to be fast and efficient. Yeah, and the point is that the server could be used across many services. So there's a database model, but there's also an API. So before the database model, let's just talk about the bigger picture. Project description. Let me just say our goal. As well, just to clarify that. We want to draft. We want to correct this draft. Correct and update this draft. we got to be careful about typing goals out in our documentation, because whenever chat reads this, it's going to get the idea that that's what we want. And we do want that in general. So I'm going to say correct and update this draft to keep up with changes in the communication server code base. Not the code base so much. Implementation that is described here. That's a weird thing to say. But we do want to correct and update this draft to keep up with changes in the specification. That's all. And the project description is, let's see. A communication server, which provides an API for requesting, how do I say it more generically? It provides an API that lets us give hooks to our programs in Python so that those third-party programs can then implicitly monitor chat generically across many platforms. So generically, it provides a unified interface for communicating with many chat services, such as YouTube, Twitch, and Discord. The server is eventually meant to receive live audio streams. Yeah, it's meant to ingest. It's more than that. It's meant to provide ingestion for audio streams. They don't have to be live. Allowing for the communication server to interpret microphone input. Remote audio streams. So someone in your chat, or some friend who's got another service, or a phone call, for example, and then you could monitor those audio sources and have them interact with the games, with the friendly feud games, and with the other services that could make use of that interesting information. To interpret microphone inputs as well as remote audio inputs. Oh, shoot. I closed it, my bad. Good, it does just open. That's great. The software is meant to run continuously without downtime. It's designed, let's just say, to run continuously without downtime. The software records all chat sources in a uniform way using a database. The software overlays the idea of a person who has who has one or more, not multiple necessarily, but one or more platform accounts, which are accounts across, let's call them heterogeneous services, such as YouTube, Twitch, and Discord. Okay. Communicating with and interpreting many chat sources. Let's say many text-based sources. Many word-based sources, such as YouTube, Twitch, and Discord. The server is eventually meant to provide ingestion for audio streams, allowing for the communication server to interpret microphone inputs, extract words, extracting words from audio is assumed. Oh, let's just say more generically that this would be the tool or the technique. By extracting text from audio with, I'm going to just call it AI, but Whisper or whatever you want to say. I guess we don't need to say how. The software overlays the idea of a person who has one or more platform accounts, which are accounts across heterogeneous services such as YouTube, Twitch, and Discord. Twitch, Discord, or a certain device. I don't want to be specific about this other platform thing. Let's just drop it. Let's just talk about the chat services. Yeah, we don't have to be too specific is the truth. I think we're generalizing correctly, and knowing how you're generalizing correctly is more important than getting the AI to understand that you know what you're doing. Keep it simple. Keep it small. It's known from literature that we reviewed yesterday that if you keep these chains of commands shorter and concise and you don't repeat yourself too often, you get better results. This is when you do iterative, stay on the same page learning. Let's see here. The software overlays the idea of a person. Let's see. This model may seem complex. It captures the idea of receiving messages from third-party chat APIs and mapping those messages to a person internal to our system. Let's say the software captures messages from third-party chat APIs and maps those, to a user of this communication service. This software captures messages. I guess these are like features, you would say. Yeah, we're kind of like, there's features, there's a goal, there's a database model, the key ideas. I mean, the goal is kind of, it doesn't have to be here. Maybe we put this at the top. from many sources. Yes, let's not say from many APIs, but let's just be generic. To a user of the communication service, this software captures messages from many sources, like YouTube, Twitch, microphones. And maps those messages to a person internal to its system. The system provides endpoints, API endpoints, for registering a listener. Which listens for patterns on all messages that are received by the server, by the communication server. On its standard channels. I don't want to call it that. Yeah. How do we call them? These are its sources. Yes. Yes, and maps those messages to a person or internal system. Nice. Okay. The system provides API endpoints for registering a listener, which listens for patterns on all messages that are received by the communication server's sources. When the communication... Let's get a new line here. When the communication server... I mean, we could be dictating here, right? When the communication server receives a message from a source, comma, it cross-checks the message across all patterns that have been registered as listeners, period. If the message matches a pattern, comma, then the system notifies all listeners on that API endpoint, period. I don't know if that's how it works. I don't know if that's how API endpoints work, actually. But that's what we're saying. Interesting choice of capitalization, Windows. Receives a message from a source. It cross-checks the message across... It compares the message. It compares the message to all patterns that have been registered as listeners. If the message matches a pattern, then the system notifies all listeners on that API endpoint with a package containing the message and person who sent the message. Should we add should we throw the whole payload in there? If we were going to throw if we're going to throw a message, let's at least attach that person's other accounts if needed, right? Let's just say that you would want different endpoints. Let's keep it simple for now. Containing the message and person who sent the message. Yeah, it's not necessary to send their accounts. The initial payload for a... Yeah. With a light payload, let's say. We'll call it a minimum payload. Containing the message and person who sent the message. Okay, this is quite a good description. Best we've had yet. goal project description. To users of the communication server, it captures messages from many sources and maps those messages to a person internal to its system. Let's say it doesn't capture, it receives on behalf of. And then the system provides API endpoints for registering a listener, which listens for patterns on all messages that are received by the communication server sources. When it receives a message from a source, it compares the message to all patterns. And if it matches a pattern, then the system notifies all listeners with a minimum payload containing the message and person who sent the message. Nice. Okay, this is sufficiently flexible, very powerful. I like this. I like what I'm seeing. I think we can just say like project description, features, technical ideas at this idea. We can be like, this is a database model. Okay, some domain entities. Yes, a person has their ID. It has a list of platform accounts and a list of roles. These can optionally be populated. I'm not sure we even need that much. These could be much lighter weight, but it's just the overhead associated with communicating them that's heavy. So let's just take it easy. It's okay to move heavy things around in the same program. And then we've also got a platform as a domain entity. The person service and a person repository. I'm just going to say program components. And then there will be some domain entities here. Just add that as a subsection. I mean, maybe those are the same thing. Yeah, I'm just being pedantic. We know what we're saying. We'll ask the AI to do a read over this and just lint filter this first specification for us. So some key ideas here. Performance of the communication server is intended to be fast and efficient. It will be used. Will be used across, it'll be used by many external services. Oh man, the server is intended to work behind a reverse proxy, such as Nginx Proxy Manager, since that's one that I use. We don't have to talk about widgets. Let's see here. Now, our system tracks and manages all messages received from all platforms, adding platform accounts when a message is received from a new account. That has not been seen before. That is not associated with a person. Not from a new account, from an account. Platform, yeah. Our system will track and manage all messages received from all platforms. The system adds new platform accounts when a message is received from an account that is not associated with a person. The system adds a new person at the same time, immediately after a new platform account is created in this way. And it assigns the platform account to the new user, to the new person, excuse me. There we go. So you get a brand new message from a never before seen chat user, and then they become a person right away. And then therefore they could be linked. Yeah. The system provides a management portal for managing the users, the persons, roles, and accounts, and person accounts. Other platform accounts, excuse me. That means platforms. Everything, right? Key features of the management portal. What's this section? Key ideas, domain entities, database model, features. It should be under features, right? Okay, good. Yep. The system will track and manage all messages received from all platforms. I think we already said that. Here we go. When the communication server receives a message from a source, it compares the message to all previous patterns that have been... Oh, shoot. Nope. Listeners. Okay, yeah, that's a good one. That's the listeners. We could just clarify that. That's like a section. Listener endpoints. Person mapping. Here we go. This is what I wanted at the top. And it provides the information to endpoints. To endpoint users. Right. System adds new platform accounts. System adds new person. Listener endpoints. This is clear. Many possible users of the endpoints. Heavy message flow. Many possible listeners. Heavy message flow. Performance of a communication server is intended to be fast and efficient. Servers intended to work behind a reverse proxy, such as npm. Okay, let's move these management features. Put here, yeah. Great job in this organization. Management portal. Key features of the management portal. Really just linking persons to person accounts, to platform accounts. How about reviewing a person's message history? Viewing, editing, listening patterns. Registered listeners. I guess registered clients. Anything else? We're going to be linking persons to... Oh, yeah, and managing roles. Yeah. Adding and removing. What about, like, add new roles, list all role holders, add role to person. There we go. On a person, I guess you say. Add remove the role on a person. On, add a person. For a person. Yeah, it all has weird implications. But basically, the system needs to provide some kind of web portal where we go to manage the roles, the platforms, platform accounts. Okay. That's a pretty good listing of the features. Let's just ask, there's nothing technical in here at all. Let's just let chat decide if it needs anything. Oh, and we should start a new project with this. File. Open workspace from file. What? Weird. Let's just reveal this in File Explorer. Yeah, and we can just take this. And it's not Stream Companion. It'll be adjacent. It is person communication server? Just call it communication server. Oh boy, yeah. I mean, it's okay for me to sync this on Nextcloud. It's just a little cringe. Okay, so theoretically then we could just, well, we can close this up because it's not even a real file anymore. But we can open a folder and just start a new path here. Welcome to a fresh project. Okay, it's going to need its own Git repository as well. So generate a new workspace. Ask chat to create a new workspace. Do I need to do that? Hopefully not. I mean, maybe. Let's just start chat up with this. What's missing from our specification? And we're just going to ask, but it's going to be expensive, right? Let's just do haiku. %81.3%. Let's go. And ticking. Enable. Yep, there we go. Okay, there's no message model. Nothing that defines the message entity structure, how messages are stored and indexed in the database. Oh yeah, true. Nothing at all. The listener pattern system. Pattern matching syntax language. Yeah, I know. We needed a language for that. It's going to be regex, spoiler. Definitely using regex. Sorry about it. Definitely using regex. Or whatever's fast, right? Because you can compile the regex at least. How are patterns stored and queried? Pattern matching performance considerations. Listener notification mechanism details. No endpoint definitions for the listener registration or management. Management portal API routes are unclear. Uh-oh. Getting in trouble for the API specification. Yeah, the management portal API routes are unclear. Yeah, because you don't need many API routes, but you do need some. If you're going to be manipulating users, you do need some API routes. But it all has to be authenticated. That's what's missing here. If you're going to have a communication server, it needs to be authenticated as heck. Oh, and that's the next point. There's no authentication or authorization here. Yeah, there has to be a huge authentication piece. Yeah, if we're going to expose API endpoints, that's why it was attractive to integrate this software directly into the Stream Companion, because then you weren't exposing any API endpoints for users. It was all just totally internal. You know, and that's generally going to be the frustration with integrating messages with external systems, because now these external systems are going to be vulnerable with this extra information. Let's just talk to chat about it. What are some of the different ways that entry developers manage the development of a secure system with a web interface? I want to provide some API endpoints because I have many programs that would make use of those endpoints. But the frustration is that developing a secure endpoint also means that these other programs must become secure. How are people coping with this? Give me your opinion as an expert, seasoned programmer who has often come back and had to revise other people's code and update and reorganize code. Modern architectures centralize the security. Clients know nothing except how to include a token or key. The API or the gateway handles authentication. And the backend services just trust the API and focus on the business logic. Okay. Okay. I'm familiar with many of these technologies here. Authentication brokers like OAuth 2 or Auth 0. I don't know what Keycloak is. API gateways like Nginx or the AWS API gateway. I don't have a lot of experience here. Reverse proxies, yeah, we're currently using Nginx Proxy Manager for that. And middleware layers. So in effect, you can still leverage these different technologies to make my own gateway secure. That's interesting. There are really only 3 sane authentication patterns today. API keys, the easiest, best for internal tools and server-side scripts. Keys can be restricted by IP, scope, and rate limit. OAuth 2 client credentials, the enterprise standard. Client logs in with a secret and receives a short-lived token. Perfect for machine-to-machine systems. Mutual TLS, extremely secure, often overkill, used when clients and servers are fixed and internal. There, use a strong separation between your auth and your business logic. And so I'm going to be looking at some security middleware. I guess that's what we're going to be developing here in large part is security middleware. Ooh, biting off more than I thought I was going to chew, but you see how extracting the user component, the communication component of this particular software, it necessitates the opening of an API. And the second you've opened up an API, now you've got to secure it. And to secure the API, I got to write extra software to secure it. And it's standard business logic. That's why I'm open to this as well. I think it's reasonable for us to take the steps to learn, to go through the process ourselves, to see what that feels like. Because it's totally standard in 2025 to be implementing a little bit of OAuth. Yeah, and the auth layer has to verify callers, decide if they're allowed to make calls, enforce rate limits, and normalize and validate data. That's like a lot of overhead. But that's it. It's like an external interface now. It's absolutely an external API that needs enforcing. Ugh. And just reinforcing here, philosophically, validating inputs at the boundary. Yeah, I agree. Yeah. All inputs untrusted until validated by the service. No dispute. Clients don't do validation. One of the biggest ways API ecosystems rot is when people break their own endpoints. Use version 1/thing, version 2/thing, and promise stability for each version. It reduces the burden on the client programs. They won't break because you refactored. Yeah, fine. I mean, we're development stage, so we're not getting too lost in that idea at this point. You could, yeah, if you're going to change the feature set. Don't change implementations. Add implementations. Yeah. This is where I start getting hesitant. Logging, monitoring, and rate limiting keep me safe when the clients are. Yeah, like if I'm going to open up an API, rate limiting is actually essential. I had no intention of talking about rate limiting at all. Like that was not on my radar whatsoever. That's needed though. That's what's needed. This was a reassuring response from chat, though. It's eminently reasonable in the modern era to abstract the security level in a way that's coherent. I can cope. A recommended architecture diagram. Here's a specification I'm working on. And let's just drop our spec in. How could we plan let's plan a security model. Answer now. Copy, edit, download, weird. Security model, API backed a web system. Oh, it's giving me like a whole document on this. Wow, interesting. It stopped talking. It's just giving me a huge response now. Oh, wow. Look, it's just going ham. This is way too much, isn't it? I don't mind it, though. Yeah, we just pull back on this. We just, like, pare back. Delete a few lines. It still talked like a robot in this response, and then it talked like a robot outside the response. It's so weird. Okay, it contains goals, architecture. Let's do a one-page architecture diagram. Build a one-page architecture diagram. Ooh, run a threat modeling checklist against the spec. Do you want the architecture diagram as an image, ASCII, or a downloadable PDF? I'd say an image, right? Yeah, let's not screw around. Draw.io, if you're able to do that, ChatGPT. Is that an option? Draw.io? Draw.io. Draw.io. Yeah, that's the one. Create another image while you wait. You love images, as many as you can get. I mean, let's just see what the first one looks like. Hold your horses, chat. Hold your horses. I just need to make a few images right away. Do you want some images? I got some images. You could be creating them now. Burn all the power in Texas. Sorry, Texas. I need these images. America, it's Texas. Thanks for the free fish. America. America. How long does this take, though? And what's with the weird Ukrainian flag thing? It's just like this weird yellow blue blob. Any indicator of percentage? Whoa, 94 percentage. I see. 95. Wow, it knows when it's going to give up. That's interesting. He's like 96% and not a minute more, Mr. Baker. Secure API web architecture diagram. And nothing more. You're joking. It's just going to sit here and just sit here. That's fine. Whoa, what? Whoa. No wonder it thought so long. This is fancy. Look at this. Okay, it got smaller there when I zoomed in on it. That's not a feature. Oh, give me 2 images as well. Okay, download that one. That's great. And download this one. No. Yeah. Download. Nice. Okay, show me these images. What do we got? There we go. Is this coherent at all? Like, I'm not an expert enough to know if it's coherent, but let's take a look. You got lots of clients, and then I've got my API gateway. Then I've got the security infrastructure. Good. We got a couple arrows here to the API gateway. That's nice. But then the auth tokens and certificates, they're flowing between my API gateway and my security infrastructure. So imagine this is our users, our person system, and then I've developed a security system on the back. And then actual backend services. I see. So people make requests through the secured API and gateway, and then all the security is conducted at a single layer. But that's quite tight. That's nice. That's simple. I mean, if this diagram is correct at all, I don't even know that it's correct. What's this like? Oh, interesting. Yeah, the API gateway is communicated with by the web browser, who then communicates with the authentication service. Interesting that the client app could bypass the API gateway and go directly to the authentication service. I don't think that's correct. Everything should be going through the API gateway, yeah. And where's that authorization logic? This diagram doesn't make that clear at all. Do they happen in parallel? Is that the idea of the diagram? The web browser connects to the API gateway. The gateway instantiates the logic. And at the same time, it's the client app that is calling through the web browser. Client app goes through the authentication service. That's what's confusing, because clearly API gateway goes, I don't know. I don't think this diagram's correct. But that first diagram, that was quite compelling. Image 1 is definitely better. In this way, if any requests are made through the API gateway, it's totally obvious to me where we should apply rate limiting and throttling. And it's right there. It's right at the gateway interface where it can check with the security infrastructure what's allowed. This feeds right into the capacity for users for persons in the database because persons have roles and the roles have limits associated with them. And those limits, you know what I mean? Roles have limits. And then limits get enforced at the gateway level. Now, currently, I'm not going to be doing any rate limiting. That's not part of the plan. Although I kind of need to, right? For security's sake, I do need to reject requests. I just want to make sure we're not throttling our own requests. For sure not. I mean, effectively, we're planning to authorize exactly one user account, and that's us. So the system that's recommended here by chat, the first system, where is it? Did it give us a list of systems here? Hold on a sec. Where was it? I thought it was in the chat here. We had like a list of options for types of implementation here. Oh yeah, here we go. Number 2, use structured standardized authentication. So we could use API keys. Easiest. Best for internal tools and server-side scripts. Keys can be restricted by IP scope and rate limit. Let's just talk about it. Why are API keys the best option and the worst option? Pros and cons. Extremely simple for clients, because clients just need to send the authorization bearer header. Nice. No OAuth dance, no complicated flows, no redirects. Yeah, I love that. I love that. And you have to keep the key private. That's fine. Again, it authenticates client applications, not users. That's how I know this is correct. That's correct. Machine accounts, background workers, exactly. It works well with short-lived tokens. Perfect for internal ecosystems. Yes, sirree. Yeah, API keys are great when used for machine identity in a controlled environment. Nice. Why API keys are the worst option. Oof. People treat them like config, so you'll oftentimes just accidentally pop it into a Git repo or a message. Yikes. Once leaked, a key is often valid forever, everywhere, with full permissions, which is a disaster. Jesus. Unfortunate. That is... Yeah, don't leak your keys, kids. Keep those keys private. Yeah, it's per app authentication, so you don't get the notion of per user audit trails, and that's actually a gift for us. Users were a redundant entity. We meant to authenticate at the application level. The most common security smell. API key with full admin privileges used for everything. Oh no. If that key leaks, everything leaks. Yeah, so we should restrict our API key to the user level, right? That's the whole point. Ugh. What does this mean? It's impossible to secure in public clients. You can't securely embed an API key in web browsers, mobile apps, or desktop apps because anyone can extract it. Do they mean because of shared cache between these entities? Like, yeah, I get why a web browser may maybe not be secure. Let's just elaborate. Elaborate on point 6. Where the code can be inspected. Yeah, web browsers, mobile apps, desktop apps. .NET or Python. Oh, and they're saying you can't securely embed it. No, obviously not. You can't. You have to distribute keys securely. That's right. That's right. Yes, no amount of TLS protects against a user who owns the machine. Fundamental rule: public clients must never have long-lived secrets. They can have short-lived tokens obtained at runtime, and they can have ephemeral keys tied to user sessions. I like this. Yeah, I like that. So if you want public clients to authenticate properly, yeah, that's the whole idea is it's a public client. And to authenticate public clients, they have to get the key somehow. And you can do a dance like OAuth 2, or you could sneaker net it and know them, and we're going to sneaker net that crap. Backend for frontend, BFF. The client communicates with your own backend. How does this work? Your backend stores the keys or the secrets, and the client sees only short-lived cookies. Yeah. It's not going to be a public client. Yeah, this won't be a public client. It's a component. It's a secure component of a bigger system. Okay, there's still some important nuances with API keys. Exactly, a backend microservice calling another service. Precisely. Yeah, which one did I mean? Is it a backend microservice calling other services? Kinda is. Like, I don't want to have to secure every friggin' front end. I want to just keep it private and secure in the back end, right? I don't think we expose anything publicly. Not at all. Yeah, let me think about that. We kind of wanted, we want this communication server to be general. So if we've got other services running behind our network, internal today frequently becomes code archived in GitHub and cloned by hundreds of people. I mean, that's kind of the goal. That's right. You run it internally yourself. That's not a bad thing. If multiple components share a key, then I lose traceability and accountability and monitoring per client. Yeah, that's right. Best and worst of the duality. And it's only fine in private system. Yeah. So just imagine that we've got this like communication server running on our main server somewhere in the complex. Then what? Then it's accessed externally, but somewhere off this network. Could be over tail scale. That simplifies my security significantly. Or we just use local addresses, also fine. Yeah, and I could just map it to a port on that machine. It's literally fine, right? Just keep it internal. Just keep it internal. I think that's great. And then that application is effectively installed in a Docker instance. And you can access its management portal. Yeah, so maybe we're not designing it to go through Nginx Proxy Manager. Let's keep this a lot simpler, right? In the future, we could do some kind of crazy, more contrived setup, but I think for now it makes sense to keep it simple. Maybe we're pulling back on that comment around securing these endpoints. Use a secrets manager. Injecting the keys at runtime, yeah, it's such a security conscious approach. Okay, API keys are probably fine then. Like that's and maybe we didn't even need to be so secure because this computer's not even this microservice isn't even going to be exposed over the internet. Yeah, right now it's going to securely retrieve communications from locations. Yeah, it's going to pull out Twitch, it's going to pull out YouTube, but it's not going to open up a hole where anyone can shove stream data yet, or where anyone can just shove words, and that's message systems. No, it has to have, it goes and it retrieves on its own. So do I need an API here at all? A lot of things to think about. It's just like you think of one part of the system that you want to implement, and then it becomes clear that there's a bigger picture at play, right? Because originally we were thinking, yeah, we'll just develop a little bit of software here. But now knowing that we want to have endpoints on a website, website. Yeah, if we want to have API endpoints on this thing, then they have to be secured somehow with some kind of more elaborate security system. So rather than just having a communication server working directly with the stream companion, you have to have a communication server that's backed by an authentication server. Security system. It's a whole security system. And now, yeah, the communication server is no longer getting access directly. It's a security system that backs an API, a public API. It's a good design pattern. It's a good design pattern, and it feels like overkill for us, but it's not. You have to have something, right? And for the sake of our development, at least this way we get, like, we know we need to just focus on yeah, public API / communication server. That's what's up. Yeah. Not what I was expecting originally. Yeah, it's a little more than I was expecting. I thought maybe we can just start reading things out. But the truth is, we need at least minimal security infrastructure to be able to set up an API for reading chat. It's not because we're exposing any of this information over a public API. It's just because it's just good design practice inside of our house. I don't like that. I think we should just avoid it. We could skip security system, go straight for a functional API, and start understanding the API structures first. Like, we're not enough of an expert in any of this to start adding security layers, are we? We're doing well on this part. Communication server we're thinking about. Like, we're getting close. Yeah, to develop a security system or to not develop a security system. Because we can skip 2 steps if we go direct to the communication server, and it is, yeah, it wouldn't translate. You would have to do a huge migration to make it secure. If you take these steps early, it's secure. But if you take them later, you have to peel up code and fix it. It's bad. Hmm. Hmm. Let's say that I develop my tool and as a microservice that only gets used internally to my local network. And similarly, my clients, they're only ever used internally. There's no exposed endpoints publicly. Do I even need a security system at all? Yeah, even for purely internal local network only non-public microservices, some form of security is still necessary. Internal networks aren't as safe as they appear. Developer laptops are not secure environments. Oops, we opened the port. Even internally, you can have accidental destructive requests. Debugging tools, spamming the AI. These are really compelling points. Like this, it just makes more resilient software if you implement some kind of security architecture. Do I need full security? No, but I do need minimum viable authentication to prevent misuse. Use network level access control. Oh, I see. Restrict which machines can talk to which endpoint. That's exactly what I was talking about. That's what authentication achieves. That's what authentication achieves, exactly. That way, firewall policies or Docker network isolation can be the whole security layer. Dude, this is what I want, yeah. Internal developer tools, small microservice clusters, embedded systems, internal automation. That's right. This is possibly all I need. I think this is all I need. I think we got to scope this right the heck down, folks. I don't think we should go ham, try to invent the world again. A whole user system with user accounts. Come on now, relax. We don't also need security on top of that, do we? So it's case B here. Yeah, and internal systems get hacked from the inside when one device gets compromised. So minimal authorization stops a compromised laptop here, yeah. I should at least have one of... Yeah, network level restrictions, simpler per client API keys. Just tell me how many services there are, what machines they run on, whether clients run on user desktops, whether you anticipate future external access. Yeah, I would say no to future external access. I don't really want this information going off-site. How many services? It would be a few services running on Windows or Linux, all on desktops on the local network. Or a laptop with Tailscale, creating a mesh net. Few services, local LAN, laptops connected via Tailscale mesh, internal clients only. Sweet. We can run very minimal, very safe security model without OAuth, without JWTs, without user accounts, or complicated crypto. Yeah, the Tailscale mesh is already the authentication boundary. We don't have to complicate this, right? We're doing a good job. It's device level identity, it's mutual encryption, it's access control by machine. Yes, 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 yes. Far stronger than API keys or passwords, confirmed. And it's definitely going to be far stronger than any crap that I put together myself. Yikes. In fact, MTLS is what big companies implement internally, and Tailscale gives you that by default. Oh, I see. If a machine isn't in your tailnet, it simply can't talk to the service. That's the whole point, yeah. And that doesn't save you because a compromised machine can now communicate to your tailnet, right? Because if you add a very lightweight shared secret, it solves the last problem. And it's optional. Seriously, I don't think we're going to even do it. I'm not going to rate limit or anything. I just want to get this tool working in a way that's locally secure. Like I'm not going to write the world's security infrastructure. There's other security concerns I have to be worried about anyway. The injection with chat is the main concern. Here we go, and we just bind to our Tailscale interface only. That's amazing. Hmm. And now I appreciate why people are just abandoning all their proxies. Like you don't need Nginx proxy manager if you just access your websites through Tailscale. And if I keep Tailscale on my phone, then my phone can access like Nextcloud, for example. See, this just seems like a way better setup, doesn't it? Yeah, it does just seem like a way better setup. Hmm. Can a machine be on multiple Tailscale networks at a time? Can a machine be on multiple Tailscale networks at a time? It does allow a device in Tailnet A to share selected devices or services with Tailnet B. So a device in Tailnet A can be shared with users in Tailnet B. Hmm. Using a shared microservice between networks, exactly. And you can share just one service or port using Tailscale ACLs. But no, you can't be fully joined into two tailnets simultaneously. Hmm. So imagine you have multiple users of your own, of your, oh, see, that's it. I shouldn't have multiple users of my Nextcloud instance. We could have a brand new Nextcloud for every user, right? That's it. That's it. You just want a brand new Nextcloud for every user. That's right. I see that. I see that very clearly. But that doesn't change the authentication. I mean, we'd all have access to each other's Nextcloud instances, but they're still all authenticated with the username and password nevertheless.
Oh man, I'd love to use Tailscale instead of authentication for my services. Is it practical? Is it practical? It really is. It really is. If Nextcloud can work on my phone over Tailscale, yeah, that's the end game right there. A lot of food for thought here. A lot of food for thought. Thank you for coming out today. This was amazing. Appreciate everyone who watched me through this development. Um, Come out on Friday. It's gonna be Factory Friday, 9 a.m. Pacific time. I'm gonna wrap out now. Maybe I'll be later. I'm definitely gonna be thinking about this development a lot. I didn't expect us to hit so many philosophical questions, but that's how it always goes. You're always learning more about what you don't know, I find. So thanks for everyone who came out here today. See you guys on Friday. Bye bye.